look at your CFU in chapter 3.1. In this chapter now we're doing two variable statistics where we're dealing with taking a look at scatter plots and all that fun stuff. So in the first problem here, we're just asked basically to find the explanatory and response variables. So let's read the problem real quick. Number one, it says treating breast cancer. Early on, the most common treatment for breast cancer was removal of the breast. It's now usual to remove only the tumor and nearby lymph nodes, followed by radiation. The change in policy was due to a large medical experiment that compared the two treatments. Some breast cancer patients chosen at random were given one or the other treatment. The patients were closely followed to see how long they live following surgery. What are the explanatory and response variables? Are they categorical or quantitative? So in this case, we want to take a look at our explanatory variable. Oh, sorry about that. I thought I had it on pen there, but explanatory. So when we talk about our explanatory variable, sorry, I forgot the A there, you're talking about what would be our independent variables. Well, in this particular case, they're comparing two different types of treatments. So we just say the type of treatment. Now the question then becomes, is this categorical or quantitative? So I ask myself, are the treatments numerical or are they like different types? In this case, they're different types of treatments. Either they're removing the whole breast or they're just removing the tumor, followed by radiation. So this would be categorical because it's either one or the other. It's putting them into one of two groups. It's not numerical. Then we have the response variable. So how are they going to measure which treatment seems to be a little bit better than the other? Okay? Well, they measure it by how long they lived after surgery. So we could think of that as survival time. If you wrote like length of time lived after surgery, that's fine. Now that one is quantitative because that is numerical. Sorry, I'm having trouble spelling here. K-I-T-I-V-E. There we go. So quantitative. Now here's the interesting thing about this. We could not actually do a scatter plot of this particular graph because in order to do a scatter plot, it has to be quantitative for both. Okay? So in question number 2, this leads to doing a scatter plot. So in number 2 it says, one of nature's patterns connects the percent of adult birds in a colony that returned from the previous year and the number of new adults that joined the colony. Here are data for 13 colonies of sparrowhawks. So the percent that return and the number of new adults. Is there a connection between the two? So in A it says, make a scatter plot by hand that shows the number of new adults that relate to the percent of returning birds. So as I do this, one of the things I'm going to do is just shrink my screen a little bit so that I can still see the data points, okay, and graph. So if I'm asked to do this by hand, okay, one of the things that I would do is start off by drawing an X and Y axis. Okay. Here's my X axis is going to be the percent of return. My Y axis is going to be the new adults. So if I look at percent of return, one of the things I want to look at is what's my lowest value, 38, and what's my highest value, looks like about 81. So as I label my x-axis here, I might not want to have this exactly be starting at 0. So what I'm going to do is put a little break in my graph, then I'm going to count by 5s. So I'm just going to move this up just a little bit. So I'm going to start at 35. Oh, this thing's off just a little bit. It's going to drive me crazy here. I'll try to fix it in a little bit here. 65, 70, 75, kind of squeezing 80, and 85. I'm running over just a little bit, but I'll still be okay. So then, for my new adults, what's nice about the new adults is it is starting as a low of 5 and 20, so I'm going to feel okay starting that one at 0. So I'm going to count by 2's here. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Sorry that the graph's looking a little bit off. My pen is not 100% calibrated, and I really don't want to do the calibration right this second. So, percent return. Oh, now it's working better. And new adults. Oops, there we go. So now I just need to go through and graph every single point. So this is going to take a little bit of time. So 74 and 5. So again, I'm just doing my best to estimate this because I know I'm drawing it freehand. 66 and 6. And 81 and 8. 52 and 11. And 73 and 12, let's see, 62 and 15, and 45 and 17, 62 and 18, 46 and 18, 60 and 19, and 46 and 20, and 38 and 20. So I have kind of a general picture of what's going on here. Okay? That's what B leads us into. In B, it asks us to describe, the direction, form, and strength. Sorry, I thought I hit red there. So direction, form, and strength of the relationship. So what we talked about today is, do we have a positive or negative association going on here? Does it seem strong? Does it seem weak? Okay. And is it linear or not? Well, if I look here, if I were to take a look at the general pattern, it seems like as percent of return increases, okay, the number of new sparrow hearts is going down. So we would say something to the extent of this. We have a fairly, I would say, strong, now in this case, negative, because it's going down, linear, so that's the type of pattern we have going on, association between, and then this is where we want to put it in the context of the problem. The number of new sparrow hawk adults, or new sparrow hawks actually, in a colony, and the percent of returning new adults. Okay. Now, in part C, it says, for short-lived birds, the association between these variables is positive. Changes in the weather, food supply drive the populations of new and returning birds up or down together. For long-lived territorial birds, on the other hand, the association is negative because returning birds claim their territories in the colony and don't leave room for new recruits. Which type of species is the sparrowhawk? Well, since it was a negative association, they would be long-lived territorial birds. So we would say since the association was negative, okay, they are long-lived territorial birds. All right, excellent. Let's flip to the second page. All right, in the second page it says, do heavier people burn more energy? Metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. We have done data on lean body mass and the resting metabolic rate for 12 women who are subjects in a study of dieting. Lean body mass given in kilograms is a person's weight, leaving out all fat. Metabolic rate is measured in calories burned per 24 hours. The researchers believe that lean body mass is an important influence on metabolic rate. So on A says, make a scatter plot on your calculator to examine the researchers' belief. Then describe the direction, form, and strength of the relationship. So what I'm going to do here right now is show you how to enter this in on your calculator. So what I'm going to do right now is enter all my mass in list 1 and the rate in list 2. And I'm going to be making a scatter plot where I'm going to be comparing the rate, I'm sorry, that should have been mass. So I'm going to change, whoa, start all over again. This is going to be mass versus rate. Now since it says to do it on the calculator and it doesn't say to draw a sketch, I still am going to draw a sketch. You won't be required to unless if it says to do one by hand. But I want to show you how you do this on the calculator. So the first thing that you want to do is pull up your calculator and enter your data into your list. Now I've actually entered my data into list 3 and 4, mainly because I thought maybe I had to do the first one on the calculator. So my lists are going to be in list 3 and 4. You can put them in whatever list you want. So pause the video right now and enter your data in, and then come back, okay, to the video when you're ready. All right, so hopefully you have your data in your calculator. So again, how you get to, if you forgot how to get to that, I suppose, you go stat edit and enter it in. It's something that you should know by now since we've been entering data in lists since chapter 1. So now, in order to do the scatter plot on your calculator, you go second y equals. Make sure all your scatter plots are off except the first one. So I'm going to select the first one. I'm going to make sure that one is on. And then I'm going to select the first graph, which represents the scatter plot. Now my data is in list 3 and list 4. So I'm going to have it be list 3 and list 4. Now I know I told you to put it in list 1 and list 2, so yours here in your X list here should be list 1, and right here it should be list 2. Mine are just in different values. Okay? So now if I hit the graph key, it's probably not going to show up because my graph window is set from a previous problem. So again, zoom 9 is zoom stat. It is a great nice little tool that gives us, okay, an idea, or I'm sorry, it's a zoom stat gives us a great tool because it fits all of our stats within the window. Sorry, got a little distracted there. So now, I'm just going to kind of sketch this in this spot. It's not going to be perfect, but it's going to be roughly close. I just want to get an idea of what the pattern is. So I had a couple points like almost right on top of each other here. It's kind of like that, and then I had, I think it was like 4 points out like that. Right? So, what's nice then is it asks us in this question to describe the direction, form, and strength of the relationship. So again, what do we have going on here? Well, looks like a pretty strong positive linear association, okay, between the metabolic rate and the lean body mass. Okay? So let's write that. We have I use moderate, but if you said, you know, fairly or moderately strong, positive, linear relationship or association, I'm going to say association, between metabolic rate and lean body mass. I couldn't spell between here. I'm having issues this morning. Sorry about that. All right, let's take a continued look at this problem as it continues on down here. Okay. So it says the study of dieting described above collected data, okay, of the body mass and metabolic rate for 12 females and 7 male subjects. In the figure below is a scatter plot, okay, for the data of all 19 subjects with separate symbols for males and separate symbols for females. So the round dots, it looks like, are the females, while the little squares are the males. So it says, does the same overall pattern hold for both men and women? What's the most important differences between the sexes? Well, if you look at the pattern here, yes, they both are positive. If I look for females, we'll do females here kind of in a pink color. You can see most of their data points are clustered here. There's our pattern. For males, we'll go blue for males. Okay. Here are the squares. Okay. They're located kind of right here. They both have a fairly, okay, same linear pattern, positive and linear. The strength, well, the strength for women is a little bit better, much closer to the line than it is for men. So that's basically our key difference, okay? So we would definitely say the general pattern of the association holds true for both men and women. But it is not as strong of an association for men as it is for women. And again, we see this, okay, by how close the points are to our linear pattern. Women, they're nice and tight and close to this line for the most part. Men, they seem to kind of fade a little bit farther away, okay, as we increase that lean body mass. All right, so this ends your video for 3.1.